Welcome back to Programming Problems, where today we shall be playing Camel cards as we close off the first week of Advent of Code 2023. Let's start. In this game of Camel cards, we get a list of hands as our input, and our goal is to order them based on the strength of each hand. One hand consists of 5 cards, accompanied by some monetary value, which will bid on the hand. Consider the following 2 hands as an example. First, we have a 3, a 2, a 10, another 3, and a king. The bid is 765. The second hand consists of a 10, followed by 2 5s, a jack, and another 5. The bid is 684. Determining which hand is stronger is done based on the hand type, for example, 2 pair or full house. If and only if 2 hands have the same type, then they are compared based on the card values in the hand in the order of the input. After sorting all the hands in our set, we can multiply the hands, one based index, with its bid. If we do this, then what are the total winnings across all hands together? Let's go to the examples to really understand the problem. First off, let's consider the card values and their ordering. They are ranked from low to high as seen on the screen. 2 is the lowest value, the ace is the highest value. Then, perhaps more importantly, let's consider all possible hand types and their values. In order from highest value to lowest value, we have the following types. 5 of a kind, where all the cards are the same. 4 of a kind, where only 4 cards are the same. Full house, where we have 3 of the same card complemented by 2 of the same card. Next is 3 of a kind, where only 3 cards are the same. Then we can have 2 pairs. Of course, we can also just have 1 pair. And lastly, we can just have a high card, meaning that all cards are of a different value. Now let's do a comparison of 2 hands. Here we have an example where we have 2 kings, a 6, and 2 7s with a total bid of 10. This hand has 2 pairs as its type. The second hand is also 2 pair, where we have 2 10s and 2 jacks. The total bid is 20. When comparing these 2 hands of the same type, we need to have a look at all the cards in order. Then we'll find that the first hand is stronger than the second, because a king has higher value than a 10. Therefore, the total winnings would be 1 times 20 plus 2 times 10, which equals 40. Note that this ordering is 1-based, so the weakest hand is on position 1, the next hand on position 2, and so on. Let's go to the solution. Since we need to order the hands, let's make the code such that the representation of a hand is sortable. In our outline, we then just need to get the hands from the input data. After this, we sort the hands list and we simply enumerate over our hands, starting at index 1. At the end, we print the total. Let's have a look at the code needed to make this algorithm work. To re-emphasize, the key is to make the hands list sortable. To do this, let's make a hand class, which shall hold the cards and the bid. Extracting the data per hand is pretty straightforward, as you can see. Before we look at the hand class, let's also make the card explicitly an object that's comparable. Is this necessary? Strictly speaking, no. But I think this fits nice with today's solution. So we'll define a card class, which just stores the character which it represents. This character, or value, shall be one from the order variable at the top. Now, to make any list of a custom class sortable, in Python we need to overwrite the less than function, which is _LT. This function gets called by, for instance, a call to sorted, and it always gets passed another card instance to do the comparison with. Then we just have to return whether the current card value is less than the other card value. Here we use the order string to get the indices of the characters of the cards. The _EQ helps us with testing 2 cards for equality. Now that we can compare cards, let's see how we can start comparing hand types. An enum can help here to make the hand type sortable, while also making the code easier to read. I added the possible hand types from low value to high value. Then finally, the hand class. We initialize this by passing in the card string and the bid value. Then we convert the card string to actual cards, store the bid, and we determine the hand type. Assuming that we have the hand type, the double_LT function is how we do the sorting of the hands. So Python's sorting algorithm gets triggered via the sorted call, which we could see in the outline, and this will start comparing hands. Then we need to check. If the current hand type's enum value is less than that of the other hand, then yes, the current hand is less than the other hand, so we return true. Else, if the hand types are equal, then we need to check the card values. This is where the comparability of the card objects comes in handy. We zip the two lists together so we can iterate in pairs of cards A and B, and then we ask, are they the same? Then we continue, as those cards don't differentiate the hands. If they are not the same, then we return the less than between A and B. If the current hand was not less than the other hand, and it also was not equal, then it simply wasn't less than, it was greater than. So we return false. Determining the hand type is something we can do by counting cards. At the bottom, you can see a visual representation of the algorithm. First, we count, via a dictionary, how many we have of each card. Then we convert this to a list of numbers that's sorted from high to low. Using this card count list, we can trivially map to all possible hand types based on just the first, or sometimes the first and second, indices of the count list. And that's it for part 1. Let's quickly jump to part 2. To make things more interesting, an additional rule is introduced. Now the letter J cards are jokers. They're wild cards that can act like any other card to make the hand the strongest type possible. However, these jokers don't take on a strong value. In fact, they are now the weakest card, even weaker than the number 2. Using the joker rule, what are the new total winnings? To make it explicit, this is the new order of the values of the cards. While the joker is the most flexible card, it is also the least valuable card. In this example, we strengthen a hand. We can see that this is no longer a pair of 2 tens and jacks, but it's 2 tens and 2 jokers, which can make a 4 of a kind. Given our setup of part 1, you can hopefully see that our outline doesn't change. The high-level problem is the same, it's just that part of the underlying sorting logic changes. Let's take a look at that. To make the new sorting work, we can just do a greedy approach, which focuses on the number of jokers in our hand. Suppose that we have 5 jokers, then we can trivially make a 5 of a kind. For all the other options, we can just remove the jokers and add them to the dominant card count. To see why this works, I made a visual example where there is 1 joker in every hand on the right. Removing this from the hand and getting the card counts gives us a clear example where we can choose where to add our joker to make the hand as strong as possible. Hopefully you'll agree that we can always add it to the leftmost card group. This extends to 2, 3, and 4 jokers as well. And that's it already again. We made it all the way through the first week of Advent of code. I hope that you are enjoying the content, and if you do, consider subscribing to help the channel grow. Thank you for the amazing growth in following already throughout this Advent of code.